Welcome to review and preview problem 743 to 748. This is Mrs. Edwards. 743 says, Felipe set his hinged mirror so that its angle was 36 degrees and the core region was isosceles, as shown below. Question A states, how many sides does his resulting polygon have? How do we know? Well, when we think of our hinged mirror, and what we are looking at is we are looking at a circle which is 360 degrees. So if we know that our angle is 36 degrees, we can take 360 divided by 36 to determine that there are 10 sides. Question B says, what is another name for this polygon? So a 10-sided polygon is what we call a decagon. Problem 744 says, in problem 741, you learned that the diagonals of a rhombus are perpendicular bisectors. If A, B, C, D is a rhombus, so if we draw a rhombus and label it A, B, C, D, with side lengths 15 millimeters. So we have a side length of 15 millimeters in a rhombus. Remember, all of our side lengths are the same. And if BD is 24 millimeters, then find the length of the other diagonal AC. Draw a diagram and show all of your work. So if we know that DB is 24 millimeters, we know that if we mark this center as E, this side needs to be 12 millimeters, and DE also needs to be 12 millimeters. We then can set up a right triangle. If the hypotenuse is 15, this side here is 12, we can solve for our other missing leg. So 12 squared plus a squared equals 15 squared. 144 plus a squared is equal to 225. Use your inverse operation, so you get a squared is equal to 81. The inverse of squaring something is square rooting it, so we know that a is equal to 9. So we know that side AE is equal to 9, and we know that AE is perpendicular, or is the same as EC, so we have to do 9 plus 9, which gives us 18 millimeters for the line segment AC. The diagonal intersects at E, and BE is 12 millimeters. (745) says, Joni claims that the ordered pair 2, 4 is the midpoint of the segment connecting the points -3, 5 and 7, 3. Is she correct? Explain how you know. So on this coordinate plane below, I graphed the points -3, 5 and 7, 3. I then found the midpoint of 2, 4, and to test to see if she is correct, we can use the Pythagorean theorem. This length is 1. This length is 1, 2, 3, 4, 5. The length of this, the bottom of this right triangle is 5, the height is 1. So when we look and use the Pythagorean theorem, 1 squared plus 5 squared equals c squared. 1 plus 25 equals 26. The square root of 26 is equal to c. So we can show that yes, she is correct. The lengths are equal by simply graphing it and looking at our slope triangles and seeing that both of our slope triangles are the exact same from one point to the next. Or you could use the Pythagorean theorem for both of these triangles and figure out that the hypotenuse of both of them is the square root of 26. For each pair of triangles below, determine whether or not the triangles are similar. If they are similar, show your reasoning in a flowchart. If they are not similar, explain how you know. So looking at example A, the first thing that comes to mind is I need to find my missing angles. So in order to find this missing angle right here, our angle CBA, I can take 180 and I can subtract 36 and 42, and I am left with 102 degrees for angle CBA. I can then do the same thing. I can do 180 minus 42 minus 102, which tells me that angle XZY is 36 degrees. I then know that angle ABC is congruent to angle ZXY. I also know that angle YZX is congruent to angle CAB. And from that, I can conclude that my two triangles are congruent in my flowchart, and I can say triangle ABC is congruent to, or is similar, is similar, so you want one squiggly, to triangle ZXY by the angle similarity property. Looking at problem B, I can see the sides of my triangles are already labeled, and I can see that 6 over 3 would reduce to 2. 6 over 5 does not equal 6/3, and I also can tell that 10 divided by 7 does not equal as well. So because these are not the same ratio, they are not similar. Looking at example C, we have 3 squared plus 4 squared equals our hypotenuse squared. 9 plus 16 equals 25. The square root of 25 tells us that the hypotenuse is 5. When we use our Pythagorean theorem to find missing side UG, we take 6 squared plus b squared equals 10 squared. 36 plus b squared equals 100. When we subtract our 36, we get b squared equals 64, which, taking the square root to undo a square, tells us that b is 8. If we set up some ratios and we take line segment FE and place it over line segment BU, we get 3 over 6, which reduces to 1/2. If we take line segment ED and place that over line segment UG, we get 4 over 8, which reduces to 1/2. And if we take line segment FD and place that over line segment BG, we get 5 over 10, which also simplifies to 1/2. So all of our ratios are the same, so we can conclude that triangle FED is similar to triangle BUG, and our justification would be side-side similarity. 747, if triangle ABC is congruent to triangle DEC, which statement below must be true? Justify your conclusion. Note, more than one statement can be true. So the thing that we need to keep in mind is when we have triangles that are congruent, it implies that our parts are congruent. So more specifically, if we have congruent triangles, it implies that our sides are congruent. And if we have congruent triangles, it also implies that our angles are congruent. So when we look at these two triangles and we know that ABC is congruent to DEC, we can tell that these angles right here are congruent because they are vertical angles. So looking at A, B, C, D, and E, none of that is talking about vertical angles. We do not have enough information to conclude that AD is equal to BE, so we can go ahead and eliminate that. Measure of angle B is equal to measure of angle D. Well, we don't have enough information to tell that the measure of angle B is equal to the measure of angle D because they are also not corresponding angles in our triangles. So we can go ahead and eliminate that. They said line segment AC is congruent to line segment DC, which is absolutely true because if we look at the sides of our triangles, if they told us we have two triangles that are congruent, that automatically implies that our sides are congruent. And when we look at AB, line segment AB, they told us line segment AB is parallel to line segment DE. So by the definition of alternate interior angles, if we have alternate interior angles that are congruent, which would be angle A and angle D, or angle B and angle E, we can then prove that the opposite sides are parallel. So we can say that C is true, and we know that because alternate interior angles of these triangles are congruent. 748 says, on graph paper, graph the points A to 9. So if we graph the point A at the ordered pair 2, 9, graph the point B at the ordered pair 4, 3, and if we graph the point C at the ordered pair 9, 6, it then asks us which point A or C is closer to point B. So what I would do is I would draw two right triangles. I know I want to connect point A to B, and I know I want to connect C to B, and we're trying to figure out which is larger. So you can write the length and the width, or the length of the legs, and then in order to figure out which one is longer, we can use the Pythagorean theorem. So looking at our first distance from A to B, we can do 6 squared plus 2 squared equals C squared. 36 plus 4 equals 40. The inverse of squaring something is square rooting it. in order to approximate which is longer, looking at it as a decimal, even though a decimal is not an exact answer, when I type this into my calculator, I get about 6.32. On the other triangle, to find the distance from B to C, I get 25 plus 9 is equal to 34. And when I undo a square by square rooting it, the square root of 34 is approximately 5.83. So point C is closer to B.